Jensen Huang just walked off the stage at CES 2026, and he didn't just announce a new chip, he announced the complete ground-up replacement of the world's computing infrastructure. If you are holding NVIDIA stock, or if you run a data center, everything you know just became legacy technology. We are going to show you everything announced at the event, starting right now. We are talking about the Vera Rubin platform, a completely new architecture that includes a dedicated CPU, a massive new GPU, and a switch system that defies physics. We are talking about a 2.5-ton liquid-cooled supercomputer rack that runs on warm water, and perhaps most surprisingly, we are going to talk about why the CEO of the world's biggest hardware company just spent time praising an open-source model from China called DeepSeek R1. This was not a standard keynote, this was a statement that the rules of the game have changed. Jensen opened with a concept he calls the double platform shift, and we need to unpack this immediately because it explains why this new hardware exists. In the past, platform shifts happened one at a time. We went from PC to mobile, or from on-premise to cloud, but right now, two things are happening at the exact same moment. First, the application layer is transforming from static code to generative intelligence. Software is no longer written, it is trained. Second, the underlying machinery is shifting from central processing units to graphics processing units. Jensen was very specific about the scale of this opportunity. He stated that there is $10 trillion worth of legacy computing infrastructure sitting in data centers around the world that needs to be modernized. 10 trillion, that is the target market for what we are about to discuss. Before we get to the Vera Rubin monster, we have to address the elephant in the room. In a move that shocked the analysts in the front row, Jensen took time to acknowledge the massive surge in open-source AI, specifically pointing out DeepSeek R1. He called it a reasoning system that caught the world by surprise. This is significant. Usually tech giants pretend competitors don't exist, but Jensen admitted that open models are now just 6 months behind the frontier. This acknowledgement validates that inference era. We are moving away from just training massive models to running them, reasoning with them, and letting them think, and to do that, you need a different kind of computer. That computer is Vera Rubin. Let's get into the specs, because the numbers here are absolutely wild. The Rubin platform is not just a GPU, it is a three-part organism. The Vera CPU, the Rubin GPU, and the NVLink 6 switch. Jensen describes this as extreme co-design. They didn't just build a faster chip, they redesigned the entire system to overcome the slowing of Moore's law. First, look at the brain of the operation, the Vera CPU. This is a processor built specifically for the age of AI. While the rest of the industry is fighting for single-digit gains, Vera delivers 2 times the performance of the previous Grace CPU. It features 88 physical cores, but it uses a new architecture called spatial multi-threading that effectively doubles that capacity, allowing it to behave like a 176-core monster. This is crucial because, in an AI cluster, the CPU is often the bottleneck, choking on the massive data streams before they even reach the GPU. Vera is designed to clear that path instantly. Then, there is the star of the show, the Rubin GPU, named after Vera Rubin, the astronomer who proved the existence of dark matter. This chip is designed to handle the invisible complexity of modern neural networks. Jensen held it up, and the size difference is visible, but the real magic is inside. It features the new NVFP4 tensor core. This is a dynamic processing engine that adjusts its mathematical precision in real time. It knows exactly when it needs high-precision floating-point math and when it can speed up with lower precision. This adaptability allows NVIDIA to claim a 5-time increase in AI performance compared to the Blackwell generation, despite only having 1.6 times the number of transistors. But where this really gets interesting, and where NVIDIA leaves everyone else in the dust, is the connection. The NVLink 6 switch is a piece of engineering that honestly sounds fake. This switch processes data at 400 gigabits per second per lane. When you stack 4 of them together, you get a system where every single GPU in the rack can talk to every other GPU simultaneously at full speed. Jensen did the math on stage. A single rack of Vera Rubin systems moves data at 240 terabytes per second. To put that in perspective, that is roughly twice the total bandwidth of the entire global internet, all happening inside a metal frame the size of a refrigerator. And speaking of that frame, let's talk about the physical reality of this machine. Jensen pointed to the new Vera Rubin rack on stage, and he wasn't kidding about the weight. It weighs 2.5 tons. The reason isn't just the silicon, it's the plumbing. This entire system is 100% liquid cooled. The fans are gone. The roaring sound of the data center is gone. Instead, coolant circulates directly over the chips, and it's not super chilled cryogenic fluid. It's warm water running at 45 degrees Celsius. This is a brilliant engineering decision. By using warm water, data centers can use simple evaporative cooling towers instead of massive, energy-hungry refrigeration units. It drastically cuts the electricity bill, which is the #1 constraint for AI scaling right now. Inside that 2.5-ton rack, you have 72 Rubin GPUs acting as a single giant brain, but a brain needs a nervous system, and this is where NVIDIA dropped the Spectrum-X announcement. This is the networking layer, and it features a breakthrough that has been promised for 20 years but never delivered until now: silicon photonics. Jensen revealed that the new Spectrum-X Ethernet switch is built using TSMC's COPE process. This means the optical lasers are built directly onto the chip package. There are no copper wires carrying the signal off the chip to a transceiver. The light comes straight out of the silicon. This reduces power consumption, reduces latency, and allows for 512 ports of connectivity on a single switch. It is designed to handle the bursty traffic of AI, where thousands of GPUs suddenly scream for data at the exact same millisecond. Jensen claimed that NVIDIA is now the largest networking company in the world, and looking at this tech, it is hard to argue they are effectively becoming the Cisco of the AI age. Finally, there was one more hardware reveal that solves the biggest headache for developers: memory. Not just storage, but context. We all know the frustration of an AI forgetting what you said 10 minutes ago. That happens because the KV cache, the working memory, gets full. NVIDIA solved this with the BlueField-4 DPU. They have essentially created a massive, shared pool of memory that sits on the network, accessible by any chip in the rack. We are talking about 150 terabytes of memory, available at 200 gigabits per second. This changes the architecture of AI applications. You don't need to cram everything into the GPU's limited RAM anymore. You can have an agent with a photographic memory that spans terabytes of data, instantly accessible. This hardware stack, Vera Rubin, NVLink 6, Spectrum-X, and BlueField-4, is the answer to the double platform shift. It is a machine built to write software. It is a machine built to serve the new humanist superintelligence that Microsoft and others are building. But hardware is only half the story. The reason we need this speed, and the reason we need this density, is because AI is moving out of the chatbot window and into the physical world. Jensen transitioned from the silicon to the simulation, and this is where things get truly sci-fi. We are talking about the Cosmos world model, the new Alpamo autonomous driving system, and the robots that are going to build your next car. We are going to cover all of that and the partnership with Siemens that is building the industrial metaverse. He said we are entering the third wave of AI. The first wave was coding, teaching computers to process information. The second wave was generative, teaching computers to create text and images. But the third wave? The third wave is physical AI. This is where the rubber literally meets the road. It is no longer about an AI that can write a poem about a robot. It is about an AI that can be the robot. And to make that happen, NVIDIA built something that might be even more significant than the Vera Rubin chip itself. They built a universe. They call it NVIDIA Cosmos. Now, you have probably heard of world models before. OpenAI's Sora is a world model of sorts. It understands how light and shadow work to create a video. But NVIDIA Cosmos is different. It isn't designed to entertain you. It is designed to train machines. Jensen described it as a world foundation model. Think of it as a simulator that learns the laws of physics not by reading a textbook, but by watching millions of hours of video. It understands gravity, friction, mass, and velocity. Here is why this changes everything. In the past, if you wanted to teach a robot to fold laundry, you had to manually code the physics or let it fail 1,000 times in the real world, which is slow and expensive. With Cosmos, the robot hallucinates the future. It runs a simulation in its head using the Cosmos autoregressive 5B model. It predicts, if I move my arm this way, the shirt will fall. It sees the failure before it happens, corrects it, and then executes the perfect move in reality. The technical specs of Cosmos are terrifyingly good. It uses a new, discrete video tokenizer that compresses video by 8 times temporally and 16 times spatially. This allows it to process visual data at a speed and scale we have never seen. And because it is open, yes, NVIDIA is releasing these models to the developer community, it is going to become the standard operating system for the physical world. Jensen showed a demo where Cosmos generated a 30-second continuous video of a warehouse accident that never happened, just to teach a safety robot what not to do. That is the power of physical AI. But where do you run these models? You can't put a 2.5-ton Vera Rubin rack in your living room, and you can't rely on the cloud if you are a developer testing a robot that needs millisecond reflexes. This led to the Steve Jobs moment of the keynote. Jensen unveiled Project DIGITS. He pulled the cloth off a sleek, metallic box sitting on a desk. It looked like a high-end gaming PC, but inside, it is a monster. Project Digits is effectively a personal AI supercomputer. It is powered by the new GB10 Grace Blackwell superchip. Let's break that down. They took the massive architecture of the data center and shrank it. The GB10 features a 20-core ARM CPU and a Blackwell-class GPU with 128 gigabytes of unified memory. That number, 128 gigabytes, is the key. It allows a single developer to run a massive 200 billion parameter model like Llama 3 or DeepSeek locally. No cloud, no latency, no subscription fees. Jensen called it the desktop for the AI age. This machine isn't just for chatting, it's for building, with up to 4 terabytes of NVMe storage and petaflop class performance at FP4 precision. Project Digits is designed to be the training ground for the robots of tomorrow. It bridges the gap between the scientist in the lab and the massive cluster in the server farm. And yes, it runs quietly, likely using a scaled-down version of that liquid cooling tech we saw earlier. But the ultimate expression of physical AI isn't a box on a desk, it's the car in your driveway. Jensen pivoted to automotive, and the announcement here was aggressive. He reintroduced Drive Thor, but this time with a specific partner and a specific timeline. He announced that Zeekr, the premium EV brand, will be launching a vehicle next year powered by the Drive Thor platform. This isn't just a cruise control chip. Thor delivers 1,000 teraflops of performance. It effectively turns the car into a rolling data center. The big news here is the integration with Waymo. Zeekr is building the vehicle, NVIDIA is providing the brain, and Waymo is deploying the driver. It is a triad of autonomy. Jensen pointed out that the car is the first robot most people will ever interact with. By using the Cosmos world model, these cars aren't just reacting to the road, they are predicting the behavior of pedestrians, other cars, and even the weather. It is a shift from rules-based driving to end-to-end neural driving, where the car learns to drive by watching video, just like a human teenager. And then, the moment everyone was waiting for, the robotics reveal. The lights dimmed, and the stage looked less like a tech conference, and more like a scene from Star Wars. Jensen was joined on stage not by executives, but by robots. Humanoid robots. We saw the Figure 02, we saw the latest from Boston Dynamics, and we saw Fourier Intelligence. But the star wasn't the metal, it was the mind. Jensen introduced Jetson Thor, the computer that lives inside these humanoids. Jetson Thor is a tiny, embedded computer that delivers 800 teraflops of AI performance. It is designed to run Project GR00T, NVIDIA's Generalist Robot 00 technology. GR00T is the foundational model for humanoids. It allows a robot to understand natural language and translate it into physical movement. You can tell it, "Please clean up that spilled coffee," and GR00T breaks that down. Identify cup, identify sponge, calculate grip strength, plan trajectory, execute wipe, verify cleanliness. To prove it works, they showed a demo using Isaac Sim 5.0. In the simulation, thousands of robots were training simultaneously in a digital warehouse, a gym for robots. They learned to walk, stack boxes, and avoid collisions in the digital world before downloading that brain into the physical robot on stage. This is the sim-to-real workflow that NVIDIA has perfected. Jensen claimed that this approach solves the data shortage in robotics. We don't have millions of years of robot data, so we generate it in the matrix, and then we export it to reality. The scale of this vision is hard to overstate. Jensen mentioned that the manufacturing and logistics industry is a $50 trillion market, and NVIDIA plans to put a chip in every single moving part of that supply chain. As the keynote wrapped up, the feeling in the room was different than in previous years. In 2023, it was about shock. In 2024, it was about hype. But in 2025, it was about scale. Jensen summarized the double platform shift one last time. We are replacing the old computer with the AI computer. We are replacing the old software with the AI model. And now we are replacing the human laborer with the physical AI agent. The Vera Rubin platform provides the raw horsepower. The Spectrum X networking provides the nervous system. The Cosmos world model provides the imagination. And Project Digits puts that power on your desk. NVIDIA is no longer just a chip company. They are the architects of a new intelligent species. They are selling the shovels, the maps, and the land in the gold rush of the 21st century. And if Jensen Huang is right, this rush is just getting started. The $10 trillion question is, are you ready for the world they are building? Let me know in the comments if you think Project Digits is going to kill the traditional PC. And don't forget to hit that subscribe button for more deep dives into the future of business and technology. I'm the CEO Storyteller, and I'll catch you in the next one.